Okay, I will begin by welcoming everyone to the first meeting of the Turba online program for this spring 2024. I have been taking a hiatus in autumn due to a high workload. But finally I've been able to organize the Turba again. This spring we will have three sessions, mostly focusing on medieval and early modern alchemy. I would like to thank the Society for the History of Alchemy and Chemistry for providing its Zoom account, and eventually the actual recording will be available on the Shack YouTube channel. Tonight, I am very pleased to have Professor Antonio Clericuzio, Professor of History of Science at Roma III, invited in the meeting. And he will talk about Thomas Willis and his chemical philosophy. Just a few words about Professor Clericuzio. He has held fellowships at several European academic institutions, including the Warburg Institute, UCL, Centre d'études supérieures de la Renaissance in Tours, and the Freie Universität in Berlin. His research studies include early modern matter theory, chemistry and medicine, focusing on the subjects of Robert Boyle, Van Helmont, and iatrochemistry in 17th century England. He has also published various essays on Italian science, notably on the Accademia dei Lincei, Accademia del Cimento, and Pietro Castelli. His current research deals with chemical medicine in early modern Italy. So please allow me to introduce Professor Clericuzio and give him the floor to talk about Thomas Willis. So please.
Here. Thank you, Joe. I'm very pleased to be back to Oxford, though virtually. I haven't been there for long. Why? Can you hear me?
Yes, we do.
Yeah. And I've been there for long. And I gave a number of talks in Oxford in the past. And now I'm very pleased to speak about Thomas Willis, which has been the subject of my research in the past. And I kept working on Willis and his theory of matter and on his chemical philosophy. Today, I'm dealing with this notion of chemical principles and with this theory of a chemical composition as contained in his early work, namely De Fermentazione, published in 1659 as part of the Diatribe 2. In this work, Willis put forward a wide-ranging theoretical framework based on the chemical principles and on fermentation. The work on fermentation provided a foundation to the tracts on fevers and the urines, which form part of the Diatribe 2. In the first part of my paper, I try and elucidate the reasons of Willis' commitment to chemical philosophy, to speculative approach to chemistry. Well, in the second part, I investigate Willis' iatrochemistry and his theory of matter, focusing on the doctrine of fermentation that played a prominent part in his early investigation. Then I take into account the relationship between Willis's chemistry and Boyle's. I'm making this comparison because, as we know, Willis and Boyle were playing a relevant part in Oxford in the 1650s and in the early 1660s. And they both conducted investigations on chemical and medical matters. And given the prominent role Boyle played in Oxford, one cannot avoid the comparison between Willis's chemistry and Boyle's, as the two of them interacted, and in my view, part of Boyle's arguments as to be found in the Scapular Chemists were aimed at criticizing Willis' theories of chemical composition and chemical principles. I start with Willis's research program, try making sense of his commitment to chemical philosophy. As we gather from Willis' casebook, at the outset of his career, Willis was engaged in chemical experiments, which he conducted mostly at Wharton College. He practiced medicine and acquired anatomical knowledge, investigated respiration, blood circulation, digestion along chemical lines. At the beginning of his career, he established links with William Petty and with Ralph Bathurst, and he soon became a prominent member of the Oxford Experimental Club. Then, in 1660, he was appointed Sedgwick Professor of Natural Philosophy, took his medical degree, and became Fellow of the Royal College of Physicians in 1664. He pursued a successful and lucrative medical career in London, where he moved in 1666 on the invitation of Dr. Sheldon, Archbishop of Canterbury. Though in the early part of his Oxford career, Willis acquired the reputation of a skilled chemical practitioner, his work on fermentation testifies to his commitment to natural philosophical themes, so much so that he devoted a large portion of his early work to lay the foundation, the chemical foundation, to his physiological investigation. And he also paid close attention to the theory of matter. At first glance, the strong commitment to chemical theories and to the speculative approach he adopted in the 1659 work might be seen as a sign of backwardness, especially if one compares it with Boyle's experimental investigations. But this view would be misleading, because as we shall see, Willis was confident that he deployed some sort of experimental foundation to his theoretical views, to his chemical philosophy, and at the same time, we should not forget that Boyle himself never gave up the investigation of the theoretical aspects of chemistry, namely the structure of matter and in particular the role of chemical principles. So the Willis' work on fermentation is based on analogies rather than on solid experimental investigation, and these analogies sometimes are affecting his chemical theories in the sense that is not testing his theories, but is just corroborating the theories by referring to chemical analogies. Having said that, I would like to stress one point to elucidate this stance of Willis in the 1650s, namely why he turned to the theory after gaining the reputation of a very skilled chemical practitioner, very skilled in chemical experiments. I argue that in the mid-17th century, as elsewhere in Europe, the status of chemistry was still controversial. And people like Boyle insisted on the importance of producing experimental facts, but at the same time, Boyle repeated that it is one thing to perform experiments, but quite another to provide a proper interpretation of experiments. So the purely practical side of chemistry was seen as a sort of limit the limitation to the activity of a proper chemist. Proper chemist should go beyond the purely experimental aspect of the activity of laboratory activity. Should pay attention to the interpretation of the experiments. This was a point that Boyle repeated very many times. So, as Boyle wrote in his early works, vulgar chemists fail to give philosophical accounts of their experiments. And always Robert Boyle referred to the natural philosopher's distrust of chemists. And so he aimed at promoting what he called a good understanding between the chemists and the natural philosophers. This is what he wrote in the Capital of Chemists. Evidently, Willis shared Boyle's view of chemistry, and he shared Boyle's effort to raise chemistry above the manual status of practical art and to turn it into a branch of natural philosophy. This is the main reason, in my view, why Willis turned to chemical investigations in theoretical terms and not just as a collection of pharmaceutical recipe, which was something quite important in his career. And pharmaceutical rationality was a very important work that he published on the basis of his experimental activity and this expertise in the production of chemical remedies. Having shared the claim for chemistry as an intellectually respectable intellectual activity, Willis embarked on an investigation of the foundation of chemistry, namely on the question of the chemical principle. The chemical principles was a matter of debate in England as well elsewhere in Europe. And Willis adopted the doctrine of the 5 chemical principles, originating from Quercetanus, Joseph Duchesne, and he stressed that there were 3 active principles: spirit, salt, and sulfur, and 2 passive ones: water and earth. Willis paid special attention to the role of spirits, and he pointed out that the spirits were the active principles performing a wide range of functions in nature. The doctrine of 5 principles, though variously interpreted, was very popular in England during the 17th century, and it was adopted by a number of English physicians, including Francis Glisson, whose Anatomia Hepatis, 1654, inspired much of Willis's iatrochemical views, and notably his view of spirits. Having supported the 5 principle doctrine, Willis responded to Van Helmont's and Boyd's objection that the substances obtained by fire analysis were not pre-existent in mixed bodies, but were produced de novo. He spelled out his answers to the Montian argument as follows, quote from Willis' De Fermentazione: "But because with some there has spread a certain suspicion that those our principles, chiefly the saline and sulphurous, are to be produced for the most part by fire, and are no ways to be found in mixed things, unless after the coming between of that, I will witness to you in some instances that this thing is plainly otherwise." So he unambiguously rejected the objection. Nonetheless, he pointed out that he did not see the 5 principles as a simple and wholly uncompounded entities, but he saw them as such kind of substance only into which physical things are resolved, that it were into parts lastly sensible. So his view of the chemical principle was a sort of a operational view of the 5 principles. These are the last substance that we can obtain by means of fire analysis. It did not engage in the more complicated position that would be the one that other iatrochemists adopted, namely that the 5 principles were simple substances, homogeneous and simple substances. But nonetheless, for him, these were the substance to be obtained by means of fire analysis, and which was exactly what Boyle criticized in the Scapular Chemists. And it is very likely that Robert Boyle had in mind Willis and Gleason when, in the Scapular Chemists, he stressed this point, namely that some natural philosophers and learned physicians accept chemical theories that, as Boyle put it, might prove somewhat prejudicial to the advancement of solid philosophy. Though Willis ruled out mechanical explanations as too remote from observable phenomena, he reinterpreted the chemical principles in terms of corpuscles, namely as particles endowed with the chemical properties with the different degrees of motion. The chemical principles, he wrote, are particles that with their motion and interactions produce all kinds of natural bodies and bring about generation, corruption, and growth. Like other iatrochemists and Gleason, Willis resorted to distillation to explain a variety of physiological processes occurring in the human body. So it's kind of the kind of analogy I mentioned at the beginning of my paper. This is maybe the most important and chemical analogy he deployed throughout his physiological investigation. His iatrochemistry was basically founded on use of distillation as explanatory model. So the extraction of spirits in the human body and also in the brain is exactly the same process that we can see in our laboratory. It's exactly the sort of process that we can produce in vitro. He claimed that the 5 principles are to be found in different proportion in all bodies and also in a living organism, and this is becomes manifest by means of distillations. From distillations, we get immediately spirits that are the most volatile and active principles. As he put it, spirits are the substance that is a substance that is highly subtle. Quote from Willis: "They are ethereal particles of a more divine breathing." End of quotation. Spirits, he argued, endeavor to fly away from bodies. So they trigger a series of chemical reactions. So they are responsible for a series of natural phenomena and also physiological processes in living organisms. Spirits put the other chemical principles in motion, convert fixed salts into volatile ones, and open earthy corpuscles, causing them to combine with other kinds of corpuscles. So these invisible active principles play a prominent part in nature and in human physiology. Willis gave spirits a prominent part in his investigation of living organisms. From their motion, he wrote, proceeded the animation of bodies, the growth of plants. They determinate the form and figures of everything, prefixed as it were, as by divine designation. The proportion of spirits and the state of activity are responsible for the properties of natural bodies. Minerals contain a small amount of spirits, vegetables larger amount, animals by contrast have a great quantity of spirits in them, and they perform emotions and also senses. So as we can see, the distillation of spirits in brain is the process that is responsible, according to Willis, for the production of animal spirits, which in turn the foundation, the material foundation of large part of brain activities, including memory and some sort of reasoning. So he was so confident in his chemical investigation of human physiology that he resorted to chemistry to explain an important part of the functions of the brain, including some sort of perception and also of basic reasoning. Like Gleason, Willis maintained that spirits are to be found in 3 different states, according to their activity. One state is when spirits are depressed and scattered, and they can hardly extricate themselves into motion. They are so involved with more thick particles that they can hardly be drawn by distillation. The second state, according to Willis, that again is following the footsteps of Gleason, is the state of proper activity. They are free to move, so they shake the other parts, digest the crude, and bring things to maturity. The last one is when spirits fly out of the body of bodies, so the decay follows. Then it moves to sulfur particles, being responsible for colors. This is typical Paracelsian stance, odors and tastes. They are thicker and less active than spirits, and like the dark spirits, they tend to disentangle from grosser particles. So a lower degree of activity is in sulfur. When sulfur's motion is moderate, sulfur particles bring bodies to digestion and maturation. But when they are a little more strongly moved, they induce heat and excess of qualities, inordination, and a stinking savor. Third, salts. Third active principle is salt. Salts can be fixed or volatile. They are fixed when they form a compound with the sulfur and earth. And so fixed salts, Willis wrote, bestow solidity on things and also weight and duration. So he explains a number of qualities of bodies by means of the chemical composition, by referring to the quantity of chemical principles contained in the bodies is investigating. By contrast, salts are volatile when their particles are mixed with spirit, so and are diluted in water. Volatile salts play a very important part in Willis, and as we know, they play a relevant part in the investigation of living organisms throughout the second part of the 17th century. Volatile salts are the agent of generation and maturation, as Willis wrote, from the volatilization of salt, beauty and fairness and savor chiefly sweet up in things, as in the florid blood of living creatures. Water and earth are passive principles, water being the vehicle of spirits and sulfur, while earth fills the empty spaces among the other principles and bestows on both consistency and bulk. A central notion to Willis' chemical philosophy was affinity. It's one of the more relevant discussion of this topic, the one we can find in Willis. I would say the first detailed account of affinity, of chemical affinity. Willis put special emphasis on what he called the cognatio in the Latin version of his works. Affinity he described as a tendency of some kinds of particles to unite with other and forming chemical compounds. Spirits have affinity with the corpuscles of sulfurs, so they produce a stable compound that is the main agent of fermentation. Conversely, some classes of particles show aversion, or rather little or no affinity to others, as for instance, spirits do not easily cohere with the salt. Sulfur particles continue to have a strong affinity with salts and bring about their volatilization, but they do not combine with water. So he made a sort of initial table of affinities. Fermentation played a key role in Willis' early works. He explained the natural phenomena, as I said, and physiology in terms of fermentation. Willis was by no means an isolated case. Natural philosophers and physicians resorted to fermentation to account for a variety of phenomena, notably to vital processes. For Gleason, whose work, as I said, was an important inspiration to Thomas Willis, for Gleason, fermentation was the outcome of the activity of spirits. they strive to unfold and to disentangle from coarser parts, breaking the bonds connecting them with the thicker particles, therefore bringing about vital heat. For Willis, fermentation was a goal-oriented chemical process, and he argued that the innate motion of chemical corpuscles was the ultimate cause of fermentation. So the innate motion of this volatile corpuscles was the engine behind fermentation. As he put it, fermentation is an intestine motion of particles, of the principles of every body, either tending to the perfection of the same body or to its change into another. Chemical change, it was spurred by the action of spirits bringing about the fermentative process. The motion of spirits, namely the endeavor to disentangle from grosser parts, brings about fermentation, which occurs at different degrees in minerals, vegetables, animals, and also in artificial bodies. When dealing with the animal economy, Willis maintained that the ferments are to be found in the main organs. In the stomach, acid digestive ferment breaks food into small particles, producing chyme, which in turn undergoes fermentation. Ferments are in the seminal vessels and in genital parts, where the chemical principles are highly exalted in the seed. The ferment located in the heart keeps blood in constant motion and, as he put it, grows impetuously hot and, as it were, enkindled into a flame. So Willis concluded, from blood circulation, fermentation depends on the life of living creatures. Willis did not detail the way ferments worked, and it didn't provide a proper definition of ferment. It just pointed out that ferments provide matter with energy. In the work on fevers, the Febribus, which is the second of the Diatribe Due, Willis resorted to fermentation to account for fevers and for a number of other diseases. Abnormal fermentation, he said, is responsible for many diseases, notably fevers, and of course when extraneous substances unsuited to the mixture are introduced into blood. Therefore, irregular fermentation and great effervescence then usually is generated in blood, bringing about feverish heat. The latter ends when the extraneous and the not mixable substance is, as he put it, either subdued and reduced or cast out of the door. Fevers might also originate from internal causes, he said. This happens when the composition of blood is altered by the inordinate motion of spirits and by the surplus of sulfur in blood. As a consequence, blood boils and puts the brain and nervous parts and raises up convulsions. Fevers may arise from a deposit, namely from the incomplete assimilation of the foodstuff. If deposits, which are analogous to wine dregs, are not eliminated, they become mixed with blood, alter its composition and motion, and intensify the feverish condition. It is apparent that besides insisting on the motion and on the proportion of the chemical components of blood, we saw illness as the result of an incomplete separation of the pure from the impure, typical Paracelsian view. The incomplete separation, inordinate separation, what is beneficial to the organism from what is harmful to it. The defective assimilation of food adversely affects the composition of blood, producing ailments. I'm jumping to the conclusion. I would like to stress a couple of points that Willis changed his mind about fermentation in the subsequent works, namely the works he published in the 60s, and he became less confident that fermentation was a sort of all-encompassing explanation of physiology, and at the same time he also reduced the role that spirits played in the fermentation. He focused, as other Oxford physiologists, on sulfur and nitre. When he dealt with blood and animal heat in the Sanguinis Accensione 1670, work that incorporates his investigation of air, respiration, and nitre. He argued that the fermentation brings about it in solid bodies, not in liquid ones. And so he said that that blood does not fermentate. He also said that life is a kind of flame, and blood undergoes the same reactions as those producing flame, namely a reaction of sulfur particles with the nitrous ones that are originating from the air. So in his works of maturity, he stressed the importance of nitrous particles, a subject that a number of scholars have thoroughly investigated, namely Debus and Frank. So I would not get into details about this, but what is important to stress here is that at some point of these investigations, physiological investigations, he dropped both his confidence in fermentation and also this view of spirits as a sort of factotum, and he focused on what became the main research topic at that time in Oxford, namely the role of air and the vital substance to be found in air, namely nitre, and deployed a theory of combustion that was relevant to physiology, a theory that took on board the role of nitre and the reaction between sulfur and nitre. So to conclude, though Willis often extolled experiments and he referred to the importance of chemical practice, his approach was very much a speculative one. He framed a big theory of chemical principles and of matter, and the theoretical assumptions were very seldom tested by experiments. The foundation to his philosophical view of chemistry was the activity of matter, a view that he took from Gassendi and also from Glisson, notably from Glisson's Anatomia Hepatis. At the same time, Willis was concerned with Boyle's chemical investigations, and he tried to revise his view of chemical principles as a response to Boyle's objection. So he adopted a sort of moderate view of chemical principles, saying that this principle was not the ultimate in nature, but whether the substance we can deal with after extracting them by means of chemical analysis. But the difference between Boyle and Willis is very clear. The role of experiments in Boyle was a central one, while in Willis the role of experiments was ancillary to his theoretical, speculative approach to chemistry. Thank you.
Well, thank you, Antonio, for this very interesting presentation and introduction to Willis's philosophy. I was quite interested about Thomas Willis, of course, and I think he's quite an interesting investigator into nature, and I always find it quite strange that he's not discussed as much in the field of chemistry as for instance Boyle is. And when you talk about Thomas Willis, it's often about anatomy and about his contributions to anatomy. And I'm just wondering if you can just briefly present your view of why you think, I mean, was Willis so, I mean, so remembered for his anatomy and so little for his chemistry? Is it because of Boyle's shadow, or is it, what do you think?
Well, of course, the most important achievements of Willis were those with the brain anatomy. And so most scholars focused on cerebral anatomy is a masterpiece. And so if one wanted to put Willis on the Olympus of big scientists active in England in the 17th century, the Willis to look at was the Willis of the anatomy of brain. But it's a difficult to, but this is a very selective reading, because if one looks at the anatomy of brain is a work, one is impressed by the pictures, which are, as everybody knows, it was the outcome of a collaboration with Rand, and also I would say the best pictures of the brain available for long, but one if one focuses on this only and ignores the fact that Willis deployed a very close connection between the shape and the function of the parts of the brain, and when he dealt with the function, he resorted to chemistry. The function of parts of brain were to be explained, according to Willis, along chemical lines. They worked as an alembic, they worked as a sieve, they performed chemical processes in the brain. So even that would be, if one did that work only and does not take into account the chemical side of the story, it is a very important part of Willis' investigations of physiology, of human physiology. That is my point, that I would say the most interesting thing in Willis is exactly this connection between anatomy, chemistry, and also the clinical practice, because he also referred to a number of cases that he dealt with in his successful medical career. He was very, very famous as a physician in Britain. So I'm afraid that this lack of interest for Willis chemistry is the outcome of I would call selective reading of 17th century chemistry, focusing on Boyle experiments as the main road of chemistry. But besides Boyle, there were other people who used chemistry, who did chemistry in different ways. And one of them was Willis, the other was Glisson, for short also Ralph Bathurst, for the same approach. So my only comment to Frank's beautiful book on Oxford physiologists is that he tended to put all of them on the same level, and he tended to give a picture of homogeneous community. And sometimes he didn't pay close attention to the differences between them, which were very relevant in my view. And as I showed, as I tried to show, this was the case of Boyle and Willis. They interacted, but from different positions. And so it would be wrong to say this is the good chemistry, that is the wrong chemistry. It's absolutely the wrong approach. That I think we should drop now.
Thank you for pointing this out. And at this point, I would like to open the floor to other questions from the audience. If you can raise, let's say, an arm by the sign, or so I can see you. Yeah. Okay. I'm not sure that's an okay. It's Thomas Willard has a question. So please, Thomas.
Yes, thank you. Thank you. And I'm very glad my meeting at 10:15 was canceled, so, or postponed. So Antonio, I was interested that you discussed Willis's engagement with the matter of aryl nitre, or potassium nitrate, as it was brought down through the rain from the air. I know that was very important to the alchemy of Michael Sendivogius at this time. And I wonder whether Willis's engagement there brought him together with practicing alchemists at the time. I believe that he knew Thomas Vaughan through Vaughan's cousin, Anthony, what's his name? The Brief Lives author.
Yes, Anthony Wood.
Yes, yes. But Vaughan was very, very much engaged with the theories of Sendivogius from early in his career. And I think they also had a common interest with Aubrey in aspects of herbalism. That they were collecting herbs in the area near St. Pancras today. Willis once stayed at the inn where Thomas Vaughan was a physician, an attendant physician of sorts, and his wife a midwife of sorts. But do you know anything about any more, or can you say more about Willis's interest in the theory of aryl nitre?
Yes, very much so. It's very important for Willis in the second part of his career, in fact.
Mm-hmm.
And it seems that it would seem that he paid very little attention to nitre in the fermentation, and so despite the fact that the view of nitre as a vital principle circulated in Britain and as elsewhere in Europe, but he concentrated on spirits. Then he somehow followed the main route that became quite important in Oxford, of looking at nitre as a vital principle. It's difficult to say who really started it. And John Mayo was certainly the most enthusiastic supporter of nitre as a sort of factotum as a living principle. Boyle was not very much was not convinced that nitre could play the role that Sendivogius and John Mayo and other philosophers claimed it had. Certainly the alchemical background and also the Sendivogian part was well known to the Oxford community and also to the English ones, to the English physiologists. What I'm not sure about is when and how Willis turned to nitre exactly the time. I would say that it happened in the very early 60s, 62, 63. Yeah. That was the time when Oxford was, a number of Oxford physiologists became very interested in nitre as an explanance of physiology, of respiration, of blood incalescence and other things. So as you said, the sources were already viable to Willis, but nonetheless, at the beginning, he found spirit as the solution to all problems. And then something happened that in 1661, Boy published The Scapular Chemist, and Boy took issue with the notion of spirit, saying that it's impossible
Yes.
to give prominence to spirit, which is a very vague notion, he said. What are chemists saying whether they speak of spirits? They put into spirits a variety of properties that should make us suspicious about this all-encompassing explanans. So Boy was the one who stressed the risk of using spirits for everything. So maybe this opened the door to some alternative explanation. And so Nitor entered the scene as a more precise ingredient of air, something that could be subject to experimentation to some extent. And that is the reason why Willis and other people in Oxford started thinking of nitre as a better solution than the vague spirit. This is my impression and this is the way to explain it, to my opinion, this turn from spirits to nitre. Nitre could be experimented. Benjamin Worsley wrote a tract about nitre. People tried to produce artificial nitre, and all the people in the artificial circle did the same. And so nitre gained momentum as a sort of principle of life, as you said, for plants, for soil. And so why not using it for other purposes, for other ends? And so the composition of saltpeter became matter of research, and was certainly more precise object of research than the vague spirits or factotum spirits that Willis introduced in his work on fermentation.
That's very helpful. If I may introduce a related question, I know that at one point in his career, but I don't know when, you can tell me, Willis was engaged in arguing against the theory of the weapon salve maintained by Flood and Digby and others. Was that when he was abandoning all interest in spirits, or at what point was he?
No, I'm sorry, I cannot trace his. I cannot find the time when he became
right.
a critique of the weapon salve.
The weapon salve. Yeah.
Yes.
Thank you.
Which everybody accepted, but more or less everybody accepted.
Yes.
Kind of Digby.
Yes, I think Willis said, well, this is Neoplatonism. This isn't the medicine.
Yeah.
Right.
Well, thank you, Tom, for that question. We have another question from Carmen. Carmen Schmechel. Would you like to ask the question, please?
Yes, thank you. Thank you, Joe. Thank you, Antonio, for the inspiring talk, and thank you, Joe, for starting this wonderful Turba series again. I'm very happy that it's happening. And I wanted to ask Antonio a question about Willis's turn against fermentation as a way of explaining natural phenomena in the latter part of his career. And of course, this is part of a larger trend. There were many natural philosophers who turned against fermentation more or less during that period. But my question would be, what role did Willis play in? So first, what role did Willis personally play in this? Was he something like a thought leader in that regard, or was he just part of the trend? And the second thing is, where exactly would you locate the between chemistry and medicine, where would you locate this turn against fermentation? Because many of the philosophers who led this turn against fermentation were also physicians. And so I'm starting to think whether maybe some of that started in medicine for some reason, but I would be thankful if you could shed some light on this.
Thank you, Carmen. Actually, Willis did not reject fermentation entirely. He rejected as an explanation in natural philosophy, but it certainly very much reduced the role of fermentation as an explanation. And he also stressed that blood did not undergo fermentation, which is a big change in his view. And there are two things: the fact that the ferments could not be found in the left ventricle of the heart, and this happened after lower developed is anatomical investigations of the heart, and also some other issues coming from the study of the composition of blood made the fermentation a sort of obsolete notion for the physicians. And as you said, it's mainly an objection coming from the physician's side, namely as an outcome of a combined work of anatomical investigation and also of clinical knowledge. So I would say that this critique came from physicians who were alert about the outcome of anatomical investigations, because it was very hard to locate these ferments and to follow the traditional path of fermentation as a process occurring everywhere, more or less everywhere in the crucial parts of the living organisms, in the main organs of the living organism. So my view, this seems to be the outcome of the medical investigation. It came from medicine rather than from the chemical expertise.
Thank you, Antonio. This is very enlightening.
Thank you, Carmen. I am wondering if there are further questions coming from our participants. If so, please raise your hand. If not, I had a question about this the 5 principle theory. Just wondering whether I mean, did he hold on to it? I mean, did he I mean, I understand that he modified it after Boyle's criticism of it. And also, did he I mean, did he pick it up from French sources, or was there a mediation through other English ones, as I don't know? And did he eventually abandon it, or did he keep it in some form of shape until the end? Thank you.
Thank you, Joe. The main, I would say, the close source to consider is Francis Glisson. I found that Glisson played a central part in Willis' early medical career and in shaping his iatrochemistry. So the mediation was certainly Glisson. I can't say that he really dropped the 5 principles, because when he published the second edition of the Fermentation, he kept the 5 principles, but he revised the status of 5 principles, stressing that they were not the ultimate components of mixed bodies. But I found that going ahead in his career, he stressed the role of chemical reactions without committing to the general theory of principles any longer. He himself said that in his early works, he was somehow taken from some philosophical fences. So he made a sort of recantation in the second part of his career, and this shows that he tended to drop the commitment to a general theory, and he used the five principles more as an operational tool, as a tool, instead of a grand theory of everything, as it was in the De Fermentazione. This shift is to be found during the second part of the 1660s. They didn't disappear, but certainly they played less philosophical, less important part in his medical investigations, also in his iatrochemical investigations.
Okay, thank you so much. Any last minute questions or inquiries? I know we started just a few minutes after 7. If not, I would like to thank Antonio for participating and for giving this very interesting paper on Thomas Willis. I should add, I think that this was there is an article associated with this, which was published recently. So if you want to know more about Thomas Willis, I think that it's a very good way to start on it. And otherwise, I hope Antonio, you will join us for other sessions if you can. Yeah, please let me know if you're in Oxford sometime, so we can discuss more about Thomas Willis and other aspects. And I'm quite curious about your research on Italian alchemy at the moment, but that's another story. There are people thanking you for your presentation in the chat. I don't know if you can see that from Catherine Fista and from Peter Oakley, and I'm sure from everyone else. And if you'd like to say a concluding word, or just thank you for everyone.
I would just to thank you, Joe, and to thank everybody for taking part and for asking very stimulating questions today. And I very much hope I can be there in person shortly, and not not just virtually. Okay.
Yes, looking forward. Okay, thank you everyone.
Thank you
for coming, and I will try to upload this as soon as possible on the Shack YouTube channel, so you can find it there if you missed anything or you want a refresher. Okay, and if possible, join me next time for a presentation by Matteo Soranzo. This is on the 26th of April, and he will talk about quite enigmatic medieval alchemist called Christopher of Paris, or Christophon, which apparently he was actually an Italian despite the name. So that's what he will discuss. Okay, thank you, Antonio. Thank you, everyone.
Thank you.
Thank you.
Good night.
Good night. Bye bye.
Bye bye.